Welcome to Aptomi. In this video, we will talk about how the Aptomi service delivery engine simplifies your microservices environment for complex applications. An application is not just a collection of its components, things like containers, VMs, or pieces of code. An application is a graph. All of the pieces of an application have complex relationships and dependencies with one another, which fundamentally affects how the application works. Ignoring these relationships leads to many problems. Because of these relationships and interdependencies, modern application delivery can be difficult. Further, gluing application components together isn't easy because we don't often know which pieces depend on other pieces. There are also Conway's law challenges. Conway's law states any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. This poses the question, how do we make teams collaborate? Because all of the pieces of an application are owned by their respective teams, we have knowledge silos, and at the same time, there is no self-contained knowledge that is applied to the operation of the services. This, combined with the need for cross-functional and end-to-end knowledge, leads to linear processes, which makes application delivery slower and more difficult. When we add in things like ops, governance, and security, which, while crucial, can feel like they get in the way of developers doing their job. Kubernetes swooped in and made container orchestration really easy. Kubernetes simplifies the process by allowing you to push manifests and images into the cluster, and Kubernetes basically takes it from there, eliminating many of the manual processes of container management of yesteryear. In reality, once you add up all of the other components that sit under your microservices environment, it becomes many parts to orchestrate in disjoint ways. You have disjoint configurations, policies, manifests, and images. To make all of this work together, it requires quite a bit of effort and quite a bit more than container orchestration and Kubernetes. Kubernetes focuses too heavily on infrastructure abstractions rather than focus on services and applications. Kubernetes doesn't focus on how application pieces interact, how services are shared and consumed, how these interactions are controlled, or how you might roll out updates without having any effect on a service. None of these questions are addressed in a way that Kubernetes reasons about infrastructure. And at the end of the day, IT policies still get in the way. They are very difficult to deploy in the current container orchestration world. There are no clear ownership boundaries or separation of concerns. When multiple organizations exist with various functions, who owns what pieces of the services is unclear, and who provides control and in which fashion is not represented. Aptomi solves for these challenges. Aptomi is a layer on top of Kubernetes and the package and configuration management layer. It provides service delivery intelligence by taking the intent of the service from the service owner, which is basically packaged code, service definition, and various rules that specify how the service is offered and how the service is consumed by others. Additionally, the service intent includes dependencies on other services and preferences on how those dependencies should be realized. Aptomi also takes the rules of the land into account, such as security rules, various governance constraints, and operational rules. At the same time, Aptomi takes into account ownership and identity of infrastructure, services, the code, the environment, and takes performance and state data and ties it to an enforcement loop and feeds it into the Kubernetes cluster and deploys applications on multiple clusters and clouds in a way that allows you to think about services and not just collections of containers. Aptomi is a distributed system that does not require centralized ownership and acts as a delivery mesh where multiple instances of the aptomi service can be combined together to provide this delivery mesh. This allows you to consume and provide services across multiple instances and multiple namespaces that transcend team or organizational boundaries. For example, each team can own an individual instance of aptomi, and it can expose itself to other teams, so the services of that team can be consumed by the services or people on another team. Aptomi can run across multiple Kubernetes clusters and multiple clouds, defined by environment-specific or global rules and policies that can do things like put caps on usage, affinities, and various forms of governance and security. Let's define services in aptomi. A service owner defines a service by pointing to the code, then specifies how the life cycle is controlled, how the resources within the service are controlled, and specifies the operational know-how of the service. The service owner then shares this service with others, such as individuals, teams, or other services, who then consume the service. Each time a service is consumed, you create a context. A context can be allocated to an individual consumer, or it can be shared across multiple consumers based on the properties of the consumer and the consumption rules specified within the service. This allows consumers to rely on a service without understanding its inner workings and operational complexity. There is also an ability to observe and control. Aptomi provides end-to-end contextualized visibility because you always know who is consuming what service. You have the complete crowdsourced application graph, which tells you why something got allocated, on whose behalf, where it's running, and who it belongs to. Aptomi also allows you to subject your service to ops, governance, and security rules. You can specify constraints such as limiting where a service can run at a given time, or who a service is allowed to interact with, all without getting in the way of people actually running the services. Now we'll look at the aptomi service model. A service definition is a collection of multiple components such as code, parameters, and rules that affect the life cycle of the service. The service is advertised through what we call a contract. Within a contract, there are multiple clauses. A clause might dictate how the context of the service is allocated to specific types of consumers or groups of consumers. A clause could also dictate whether the service is a private or a shared instance, and in the case of a shared instance, how it will be shared. For example, if we are to allocate multiple shared instances per sets of consumers or otherwise. In this example, we have production shared for our production consumers. We've also created production private for important consumers, giving them dedicated instances, and stage, which might have different code or scaling characteristics and different placement parameters. We also have dev test, which points to a completely different piece of code. For example, we are pointing to a mock or a fake piece of code that simulates a certain function. Now, as a consumer, you don't know which one you're going to get. For example, let's say I have a service that offers an SQL database, and for very important users, you're providing MySQL. For other users, I might offer a lesser database that doesn't require any licensing. Services and components can depend on other services. As a service owner, you know which things your service depends on. Your consumers consume your service by relying on the contract. This allows you to obfuscate the inner workings of the service from the consumers, so you don't need to understand what's going on operationally within the service. You're only dealing with the contract. This model provides a very nice self-contained way of defining services and how a service operates. It provides very tight ownership boundaries since this model is controlled by the owner of the service. Out of all of these pieces, aptomi stitches together a complete application graph. Each node in the application graph is essentially crowdsourced by the respective service owners. The big picture is stitched together from all nodes and services. Aptomi can be controlled from an IT perspective from service and infrastructure policies and IT service policies. For example, you may dictate a particular service may run with redundancy in production, but no redundancy in the staging environment. You might also confine certain labels to a particular cluster, such as a service labeled test must only run in the US East cluster. You could also use a label to move the service to a new cluster. Labels could also be used to control security and compliance. For example, you could constrain production to only run certified container images. Or you could ensure untrusted workloads are quarantined from sensitive workloads. Or you apply constraints on things you pay licensing fees for. For example, limiting MongoDB Enterprise licenses to 100 to control costs. For dev test services, you might mandate dev teams cannot deploy to production, and further add each dev gets their own instance of memcached in stage. You can also optimize your utilization by specifying a rule to terminate test instances overnight in a particular cluster. Aptomi's rules provide powerful security, governance, and operational control and enforcement. In summary, Aptomi simplifies rollout and operation of container-based applications and services on Kubernetes and introduces a service-centric abstraction focused on understanding the relationships between application components, rather than today's infrastructure-centric approach. Thank you for listening. Please visit us and join the conversation in one of these channels. Thank you.